My name is Jay, and I'm here to explain question 4 and 5. For question 4, we have to evaluate the x-intercept of this equation, and for that, we have to use the quadratic formula, which is minus b plus minus square root of b squared minus 4ac over 2a. For the first x, I put plus. For the second x, I put minus. However, since the discriminant is smaller than 0, there will be no real solution and no x-intercept. For 4b, we have to express this function in the form of a complete square format. For the a, we can put this a here. For m, we have to use b over 2a. And for n, we have to use c minus b squared over 4a. For question 5, we have to explain how ABC affects this graph and how to make this graph match with this graph. So for A affects how wide the graph is and where the parabola will be, whether it's going up to down or down to up. For B affects whether the graph is going left or right. And as for C is the y-intercept. And there we go, it matches. For 5b, we have to find a better way to match the graph instead of using this trial and error method. For what I did, I used simultaneous equations. I found 3 points on the target curve, which is over here. I used the first point to find C. Since 0 will be sub in to the x, A and B will be cancelled out, and C will end up being 17.482. Using the second point, same, I sub in x and y, and end up with this. For C, I sub in C equals 17.482 here. We'll end up with this. This will be equation 1. Lastly, I use the final point and do the same steps that have ended up with this equation. However, I would like to make the b's the same so I can minus them off easily. So I multiplied this by 3 over 4, which gave me this equation 2. Then we subtract both equations, 1 and 2. We'll end up with A equals this. We sub A equals this into equation 1. We'll end up with B equals to this. And as you can see, A, B, and C will end up being A, B, and C. Thank you.